Invite Brian to have a seat, and I'll call up onto the stage our other panelists. See if I can get this slide to work correctly this time. Yes. First of all, Gerhard Goes. Bob McClure. Doug McElroy. And Manfred Paul. So they've come up a little bit out of order. That was first Gerhard, Manfred, Bob, and then Doug, of course. Okay, and at this point, we'll have a somewhat informal conversation with these gentlemen. We have a couple of questions of our own that we would like to ask them, and then hopefully we'll have a little bit of time at the end to hear questions from you. Once again, we have microphones at the front of the room and also along the aisle there between the two sections of the auditorium.
Okay, I think we can get started, right? So I'll start off with hopefully an easy question, which is not going to be unexpected, but I'll put a caveat in there as to what you can give as or what you cannot give as your answer. So from the meeting, the conference you had in 1968, what did you expect coming out of it, and how does that differ? In what ways did the world surprise you? And possibly in what ways did it disappoint you, the world of software engineering? And the answer you cannot give is the conference from 1969. So that answer is off the table. So in any order you feel comfortable.
Well, we start there.
Well, from my point of view, the conference in '68 was already a consolation. Fritz Bauer had tried to produce a software engineering institute starting in 1966. I was myself involved in those talks in '67, and the conference in '68 was there to explore the field and find out what should be done or could be done. That was the main point. What I got from the conference was the importance of requirements engineering. That was positive. But software maintenance was a completely neglected field. It happened at the end of the software life cycle and was a small piece. And the fact that 70 or 80% of our time goes into software maintenance, that was not known.
Okay, thank you.
Well, I believe that what was the most unexpected result in the last 50 years is the tremendous mass of data that we can handle nowadays. To the extent everyone can realize, if we just ask any question whatsoever, the answer is almost at present in a minute or maybe in a second. You may believe that this is so for all the time, but that was not so in '68. I can tell you it was a very, very hard thing to find something which you knew was somewhere there. That was the most unexpected. And the most disappointing is I find it particularly very deplorable that we have not yet found efficient methods to either prevent or even bar the misuse of electronic and social media. That is a catastrophe. Every day we have bad news about fake informations or misdirected data, regardless whether they are done unwittingly or with criminal intent. Apparently, that's my main idea. Apparently, there are too many informaticians and/or users of social media who simply don't observe the unwritten code of good practice.
Thank you. Bob?
In 1968, I had just come off a 10-year career in industry, but not academia, and I had joined Southern Methodist University with the thought possibly of becoming having an academic career. And since I was in a newly minted what was called computer science curriculum, I had no real earthly idea what needed to be taught to people to be able to practice what was certain to become a major source of employment for the country, because it was pretty clear at that time that computers were going to become ubiquitous in our lives and they would all need software. I had started as an electrical engineer, electronics engineer, for which there is a long discipline, and I was hoping that we would find the same historical disciplines for software. And I listened to these papers. I was enthusiastic because a lot of people said things that I thought was very good. I took it to heart. I went back and I developed some programs along those lines. And then we came back a year later, and I came to the Rome conference. And in echoing what Brian had said, I found that it was a serious disappointment because effectively no progress had been made. Nothing had been done to really establish what I call a true engineering discipline, which he recited several quotations, which I won't recite again, to that end. And that's basically my view. I was very optimistic in '68, much less optimistic in '69.
I was sent to Brussels by Ed David, who was our director at Bell Laboratories at the time, to participate in the creation of the list of invitees. It had already been decided that this conference would be held. And as it was said, there was some subtext, but I don't know, I am not really cognizant of where it began, that this might lead to a NATO institute. It's the only time I crossed the Atlantic Ocean in first class, because it was a one-day trip to Brussels and back. Somebody had put together a very good list of contacts around the world to create the list of people who arrived at this conference. It was eye-opening. It was exciting just for the title. That put a new perspective on the business we were in. The word computer science had been invented a few years before, and departments were springing up around the academic world on computer science. Sometime later, Fred Brooks said, if you have to call it a science, it isn't, and citing Christian Science and mortuary science as evidence for that. And I asked Fred about that this morning, and he said he effectively said it shouldn't have been called computer science. It should have been engineering, because that is the topic of what we do when we build both computers and software. After the conference, the hope was that this would become a real engineering discipline. One of the a modern requirement for engineering is that there's some science behind it. And one of the things that's pleased me since the conference is the rise of formal methods. And one of the things that's disappointed me is the fact that, at least in the United States, they have not been accepted as part of standard practice. I think that's all I wanted to say at this point.
Thank you. Brian?
I don't really have much to add to what I've already said. When I mentioned that several people said that the 68 conference had changed their view, one prime example would be Edsger Dijkstra. He and others were very much motivated by discussions at that conference to start thinking in terms of formal methods of producing programs that were intended and expected to be correct ab initio. I find it, in retrospect, quite funny that a year or so later, the effect that it had on me was of getting involved in the idea of what can we do to increase our ability to depend on software that we know has got bugs in it, but we don't have any means of guaranteeing that we've got rid of them all. And essentially of extending the notion of fault tolerance from hardware, where it was well established, to software. And that was a subject that I then spent with colleagues many years afterwards, and which I still think is an appropriate complement to work on formal methods. I think it's a very good idea to try and make sure your software has got no bugs in it. It's a very bad idea to put your complete reliance on having succeeded.
Amplifying that, on that a little bit, I expressed my disappointment in formal methods not being accepted much. They've barely begun to percolate into IDEs. And in fact, if I look at a modern IDE, the first time I saw one described was at the 1968 conference. Bob Beamer effectively described a modern IDE there. His IDE didn't happen to have syntax coloring, something that I've never understood myself. Would you read English language? Prefer to see your novels with the adjectives a different color from the nouns? So indeed, our accepted practices in managing projects, which lead to the universal use of IDEs, just hasn't absorbed any of the science lessons, or many of the science lessons that we have learned in the interval.
Over the years, I've given several talks concerning the distinction between science and engineering, and it's strictly applicable to computer science and software engineering. That is, that science really is concerned about discovering the truth, new information, learning. Engineering is concerned about finding a good, if not the best, compromise. And designing software is always a compromise, and therefore it should be called engineering. However, we have not yet developed the technology to discover what really amounts to what is a good compromise. We don't know. This is always left up to the individual who plucks his ideas right out of the air. And he says, I'm going to do it this way as opposed to that. Simple example. You can write a 3-line software program which is guaranteed to work under any and all circumstances. It may run slowly, called an exchange sort, or you can write a very complicated sort, which will run very fast most of the time. Which one do you pick for a particular application? Always up to the individual. We don't have any techniques whereby we can make that rational choice outside of just leaving it up to the man who did it.
I should like to make one remark regarding the 68 conference, which has nothing to do with the immediate result and whatever it seminates in the following the future. That was said by Brian very nicely and very fully. But I want to say what seems, if you haven't read the report, then you don't know that more than 50 attendees were there from 11 countries, including even the partly countries behind the Iron Curtain. And there was almost an even split between academia and industry. That, I think, is something which was very, very fruitful for all participants in that conference, particularly that industry was there, not only academia. Now, in this, at this point, David Rosenblum has asked also, what about Article 68? Did it play a major role? It's an interesting question because Article 68 was ill-advised from the beginning and did, of course, did create very heated discussions, but not so much in the Rome meeting. There were some critical remarks, but it did not go into depth discussing that. I just say it died out, as most of you may know, very soon, because in Working Group 2.1, which had a meeting the same year, 68, it was heated, very, very, heated.
There's
and
one.
Where the British, mainly the British participants, members of our group, who made clear that this is impossible. Impossible development which leads to nowhere without helping anyone. And so Article 68 died. But then I want to make at least one defending word for Algol, the Algol as such. Algol was, as only very few people whom I meet today in meetings and talk with them about Algol, they don't really know that Algol played a very, very important role in these days that we are talking about now. Between 62 and 65, probably even a little later, there was a group formed by universities in Europe and the University of Illinois in the USA, called the Alcor Group, and they had a normed part of Algol, mainly Article 68, as it was published with minor reductions. And this compiler was normed by this part was normed by a compiler called Alcor. And those universities who formed that group really used the same language in their compilers, whether it's IBM 7094 or whatever it was, or any European computers at that time. A normed language that could be used for publishing mainly numerical analysis procedures. And that it did not really live longer than about 10 or 12 years as a compiler, as a language used, is really not the reason that it was not worth it. That quotation was used today already by Professor Brooks in the morning. That is it worth considering quotation of Niklas Wirth, who was working in this area also. Now, that's what I wanted to say, that Argol had some impact on the development later. What it missed and what it forgot was to add the class concept, which first in 1977 with Ole Jan Dahl from
67.
Norway in Simula 77.
67, Manfred. You've missed 10 years. 67.
67, thank you. Okay, thank you. There you find the class concept, which is so important, of course, in modern languages as Java. That was a failure of Argol. Okay.
Thank you.
One aspect of the conference, nothing to do with technical, is worth noting, and it's been repaired. There were no women participating. At the time, I wasn't even conscious of it, and that says a lot.
I'll also make the comment that every man wore a business suit and a tie.
Is that good or bad?
I'll make some comment about languages. He commented that the Hopel list of 8,900 and some odd, I haven't examined it and done the counts, but I would doubt very seriously that more than a double handful are used by more than 10 people today. There are a lot of what I call personal languages. I've got a few myself that people use, and they say, of course it's in use. I use it daily, but it's not used by anybody else. If you look at the history of languages, a very large number have come and gone. For example, PL1. Does anybody in this audience remember PL1? There are a few. I see some hands. What about Algol? How many people have actually written a program in Algol? There are a few people who've done that too. How many people use them today? I don't see any hands. Now there are
two hands up there.
Yeah, there are a couple. I'm not saying there's nobody, but remember I was saying the body of people who use some of these languages is extremely small. I am told that there are, something like 8,000 human languages in the world, of which the vast number are used by less than 100 people. And I think that's probably true. That's the way programming languages are headed as well. They will be used, but only by a very few people.
Okay.
Something I couldn't squeeze in this time, but it's in one of all these other reminiscences, is a lovely quote from a British academic 10 years ago, listing all the different languages that he and his colleagues found they were having to mark student projects on. He lists a long list of language, a ridiculously long list of languages, and suggests that probably the only thing that was missing was Etruscan.
Okay. I was personally involved in the design and implementation of ICSE2018 at that time, but I did not see any direct correlation between software engineering conference and these language issues. But it was clear at that time that the progress in producing software would not come from the improvement of programming languages. And I think that's true also today. My personal consequence was when I moved from Munich to Karlsruhe in '71, I acquired a Simula 67 compiler, and my students were probably the first ones in the world who learned object-oriented programming already in 1972, 20 years before everybody else did. So much about the correlation between language and software engineering. But another problem was that the Garmisch conference had much too much focus on management problems. Clear, management of software teams is an important part for every director of software development. But management is not a part of software engineering. It's a part of social engineering. And that has been tossed together in much too much in '68 and in the years afterwards. It's only now that we restrain and come back to the fact that software engineering is concerned with properties of software, not with properties of the people who do it.
Okay.
And that those things should be separated. As far as the Rome conference is concerned, my complaint is that already in the Garmisch conference, design and implementation of software were seen as something which falls together, in contrast to other engineering disciplines, where design is preparing for production, but production is a separate issue. But in software engineering, we have that together. And that's a mistake which goes on also today, that design issues and production issues, programming issues, are convoluted and are seen as being one piece. We should much more concentrate on the idea that we need to design software as consisting of something which you may call components or modules or statements or whatever larger objects you have. And that afterwards, the production, which is programming, is a different issue. And the Rome conference in particular had the problem that they mixed that up with the result that everybody who was experienced in programming meant that when he is speaking about programming, then he would cover the kernel of software engineering, which is definitely wrong. And that was a failure.
So,
oh, sorry, just one quickie. The word components was used then. One of the things you should definitely read or reread in the '68 report is the text of Doug's talk on components. He was suggesting that the lack of standardized families of components and abilities to build systems out of sort of parameterized components was one of the major things that was needed. His talk even now makes you realize how far we've still to go, but it is noticeable that in the years that followed, at least one world of absolutely splendid system building using components, the Unix world, did flourish. Yeah. And of course, Doug was slightly involved in that.
Yeah. Yes, maybe let Doug have the final word then before we have to close off this panel, unfortunately.
I have one question for everybody. There were 55 attendees at the 68 conference. There were a few more at the 69 conference, but only 20 of the first at the 68 conference attended the second. I don't know why that number was so low. Does anybody know?
Well, in my personal case, I was invited to the conference, and I saw what was on offer, and I'm afraid it just didn't live up. It didn't live up to its title, Techniques of Software Engineering. It was going to tell us how to do what we had said we needed to do. And it just didn't look like it was going to, so I didn't go to Rome.
You anticipated the problem.
Okay, unfortunately, I have to play the bad guy here and close off this discussion. I mean, these guys have made the job very easy for me and Nino. They had a very nice conversation going here, and unfortunately, I'm going to have to be the one to cut it off because I know we are on a very tight schedule for the rest of this session and also to make it to the banquet. I believe these gentlemen will be attending the banquet this evening, if I'm not mistaken, so you'll have an opportunity to chat one-on-one with them in person. I'm sure they'd be very happy to chat with all of you, share some additional stories.
Or 1-on-5, really.
Or 1-on-5, however it works out, yes. But please, once again, join me in thanking these gentlemen for making their way to this conference and sharing their reminiscences about the 1968 conference. Okay, so now we'll have a